Hi everybody, this is Mrs. Ewald signing in, and today we're going to cover covalent bonds and Lewis structures. So, to start off, these are the learning objectives for today. First one is to define and give examples of covalent bonds. Also be able to draw an electron dot diagram or Lewis structure for both atoms and molecules, and you can find that in 12.6 and 12.7 of your book. And lastly, explain the difference between ionic and covalent bonds using the element's location on the periodic table as well as electronegativity. Now, Ms. Heaton in her last podcast went through ionic compounds, ionic bonds, as well as a little bit going over the different types of periodic trends in electronegativity. I'm going to show how this is also important when we start covering covalent bond. So at the end of this, you should be able to start organizing, maybe in a graphic organizer, and go through what is ionic, what is covalent, and then be able to tell the similarities and differences between the two, identify them, also be able to write formulas for both of them. So as far as the structure goes, covalent molecules are formed when atoms share electrons. This would be the definition. So covalent bonds share electrons, and you learned earlier that ionic compounds, well, they transfer electrons in order to make a bond. And so by that sharing of electrons, we are also talking about with covalent, these are all non-metals. And so you should know on your periodic table that we are referring to, if I draw a quick sketch here of the periodic table, you have your metalloids over here on that staircase. We're referring to only this section here as well as hydrogen. So those are going to be your nonmetals involved in covalent bonds, and we're talking about the sharing of electrons. We'll cover a little bit more when we talk about polarity, how, just like maybe with your siblings on Christmas, you may share equally or not equally. So this here is a visual showing you an ionic crystal here in this visual, how they, because of those charges, they're so strongly attracted to each other. It's a very strong bond. Versus in covalent, you don't have those charges, but what we have is the electronegativity, which helps us to explain why those elements are electronegativity, why they are attracted to each other. And when they form these molecules, it does not look the same for ionic. So that visually, hopefully, shows you the difference. This here explains, too, how the orbitals are formed. And when you have the covalent bonds, those electrons are shared in those outer orbital, those outer valence electrons. So we're also referring to valence electrons, just as we did with ionic. But again, now we have the sharing of those electrons across those orbitals. So electronegativity, if you remember, is the tendency of an atom to attract bonding atoms to itself. And so fluorine is the most electronegative, and francium is the least. So as you move up and over to the right, the more electronegative it is. And so if we are only looking at our nonmetals here, so we're looking at these over here as well as hydrogen, this helps us to explain who is going to bond to who, and it just helps us to figure things out too. We'll talk about this more later when we get into polarity. Excuse me. So as far as covalent goes, again, covalent is between nonmetals, and it is when they are sharing electrons. And so we could visually show the sharing in Lewis structures. So these are, I kind of put these together in 5 smaller rules to kind of think about this process as you go through. So you're going to count the number of total valence electrons of that molecule first. Then you're going to connect the atoms by covalent bonds. When we connect with a covalent bond, we're going to have one electron sharing with another electron. And so we'll connect it with a line. This shows you and represents a bond. We're going to then subtract the number of electrons in the bonds from the total number of valence electrons, and then add electrons in pairs so that the atoms have 8. Remember, they want to be like the noble gases. And hydrogen wants to be like its noble gas closest to it, which is helium. And so it will only have 2 valence electrons. It's the only exception we'll look at. And if atoms lack an octet, what we want to do is keep adding double or triple bonds until all of them have the full set of electrons needed. So really quickly, going through this, if we look at hydrogen, so hydrogen has 1 valence electron. And if we want to make a hydrogen molecule, it's very easy to see how it's going to want to have 2, just like helium. And so we will show that covalent bond. You could also represent it like this, with just the dots showing a bond has formed. If we look at fluorine, for example, fluorine, you should know from what we looked at before with valence electrons, fluorine, if you look on the periodic table, has 7 valence electrons. And so according to Lewis structures, what you could do is you could show those electrons, again, as these dots. And so fluorine would have 7. And this fluorine would have 7. And so what's going to happen is that these are going to come together to make a bond. So it would look like this. So this is a simple way of showing, and again, you could also visualize it too with just the all dots to make a dot structure. And now, if you count them all up, this has 2, 4, 6, 8. So this one is completely full. 2, 4, 6, 8. This one is completely full. So this helps you to see how fluorine, according to Hankel-Briff, fluorine is going to be very stable when it is together with something. Same thing too with hydrogen or chlorine or bromine. You could practice that with any of them. So let's do some more examples of this following those same procedures and then doing a Lewis structure showing how they come together. Now let's hold off on CO2. Let's first start with HCN. So when you see something written like this, first off, you could probably just keep it in that order. So otherwise, we always want to make sure we keep carbon in the center. So we're going to have H, C, and N. Now, again, hydrogen is going to want to have 2 in order for it to be happy, or in order for it to have a full valence shell. Carbon needs to have 8, and so does nitrogen. So the first thing to do is count up our total number of valence electrons we should see in our structure. So hydrogen, if you look on the periodic table, is going to have 1 valence electron. Carbon has 4, and nitrogen has 5. Again, where am I getting this from? You should probably look back at your labeled periodic table that you already did in the first podcast, where it shows you, we're only really looking at the S and the P here. So this would be 1, 2, 3, 4, 5, 6, 7, and 8. And so I'm looking at this in order to determine that. So altogether, I should have a total of 10 electrons on my structure. So the first thing I'm going to do is just connect atoms by covalent bond first. So that will be 1, 2, 3, 4. So I'm going to just draw a line to show that those are bonds between the 2 of them. So between carbon and hydrogen and carbon and nitrogen. Now I need to have, well, I have 10 electrons total, 2 and 4. I've already used 4 of them, so now I only have 6 electrons left in order to show. Now the question is, what do I do? Well, I need to make sure that carbon has 8. And hydrogen's already happy with what it has. It has the 2. It's just like helium. Now carbon and nitrogen need to both have 8. So if carbon already has the 2 here, I'm going to have to start adding double or triple bonds in order to make everybody happy. So I'm going to add in, so that's 2, 4, 6, 8. So that gives this. Hydrogen again is happy. It has its 2. Carbon now has 2, 4, 6, 8. So carbon is happy. Nitrogen has 2, 4, 6. Now, I've just now used 2, 4, 6, 8 of my total 10, so I have 2 electrons left, and I'm going to place them here by the nitrogen. So now when I go through and I double check, I'm going to add everything up. Hydrogen has 2, so it's good. Carbon has 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. And so you could just also just show it like this. And that would be a Lewis structure with lines instead of all dots. CH4. So carbon is going to have 4 electrons. Hydrogen will be 1, but we have 4 of them. So we should see a total of 8 valence electrons in our structure. Now carbon, again, is really nice to put in the center. You should learn this from biology, how carbon, you have the carbon backbones, you make many different macromolecules with it, and carbon can also make 4 bonds. And so what we're going to do is we're going to first bond all of our hydrogens, because hydrogens are really good at wrapping around a molecule, and carbon will keep in the center. So watch what I do. I'm going to make a covalent bond with 1 hydrogen, another hydrogen, another hydrogen, and another hydrogen. So this is 1, 2, 3, 4 bonds. Each of my hydrogens is making a bond, and they have 2 valence electrons now because they are sharing. Carbon has 2, 4, 6, 8 valence electrons wrapped around it. And so looking at all of them, I have made them all complete. So I have 8 valence electrons around carbon, 2 valence electrons for each of my hydrogens, and we're good. You could also show it like this. So depending on how your teacher would like for you to represent it, you could show it either way, either with a line representing, understood that it's 2 electrons, or with the actual dots. Let's try NH3. Nitrogen should have 5 valence electrons. Hydrogen would have 1, but we have 3 of them, so it would be 3. So this would be 8 valence electrons total. Now, again, hydrogen's very good with wrapping, so let's go ahead and put nitrogen in the center. And now I'm going to first make my bonds, my covalent bonds with my other 3. So this will be 1, 2, 3. So that's 2, 4, 6 electrons. So I only have 2 electrons left in order to show. Now I check my hydrogens. They have, full octet, full octet, full octet. My nitrogen only has 2, 4, 6. So what I'm going to do is add 2 more on top of my nitrogen. So to show you a cleaner way, you could also show it like this. Again, each one of those there representing a single bond. Now let's go back to CO2. So carbon has 4. Oxygen is going to have 6 times 2, so that would be 12. So this should have a total of 16 valence electrons. I'll do VE. I really should be doing VE for valence electron. I'm going to place carbon in the center. Just notice the trend. We're going to keep the carbon in the center. And I'm going to place, first I'm going to make a bond with each of my oxygens. So this will be 1 and then 2. So out of those 2, I've used up 4 electrons. And so I only have left then 10 to use up. Oh gosh, no. And I can't do math here. So 12 valence electrons left. I'm just making sure you're awake, that's all. And so now what we're going to do is, just as we've done before, make sure that they all have their 8. And because we don't have hydrogen here, each one of them needs to have 8. But we have to be careful. Watch what I mean. Now some of you might want to right away say, oh, okay, they each need 8. Well, I'm going to go ahead and do wrap this. That gives that 8. I'm going to wrap my carbon. That gives 8. I'm going to wrap my oxygen, and that gives 8. But wait. Where's the boo-boo here? That makes this 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So clearly you would think that this would be okay. But I can only have 16 valence electrons total in my structure. This has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh no, that's 4 more than what I need. So watch what I do. I'm going to show you how what we could do now instead is put in some double bonds. So I'm going to remove these and I'm going to put in a double bond, but I'm also going to need to remove extra pairs here because I've put in those double bonds. So watch this. It would now look like this. So my carbon has, wrapped around it, 2, 4, 6, 8. My oxygen also has 2, 4, 6, 8. So this has 8, and this oxygen has 8. And they're sharing between those two with this carbon. And now when I count this up, it has 2, 4, 6, 8, 10, 12, 14, 16. It's perfect. It's the way it should be. So I would try to follow that methodology when you go through these next 3 on your own. For real, try them. And you want to make sure you have these to show me and Miss Heaton when you come to class. All right? So this is Mrs. Ewald signing out. Happy covalent bonds and Lewis structuring.